Hello, this is Osama, and today I'll be presenting a presentation plus demo on containerizing and deploying microservices on k8s reliably. The target audience for today's presentation are the enterprises who are looking to adopt containerized solutions and strategizing on how they can adopt containers. Dev and ops team who are looking for shorter delivery cycles and targeting reliable software deployments, and CXOs who want to calculate the return on investments on containers and Kubernetes adoption. Okay, so my name is Osama. I am currently working as a lead DevOps engineer at Stackator. I am a Kubernetes enthusiast, and I am certified Red Hat system administrator, Red Hat certified engineer, and Red Hat certified OpenShift administrator. So let's start by knowing containers. So Google Cloud defines containers as lightweight packages of your application along with your dependencies, which are locked on a specific version and packaged along the runtimes and libraries so that your application can run. And if you look at the market trends for 2020, there was a study that was done by Dell, which showed that 20% of the organization are using multi-cluster orchestration in one way or another. So platforms like Kubernetes, OpenShift, and other container orchestration platform. But 88% of the enterprises have deployed containerized application, their own or the third-party services, in one way or another. So this basically suggests that the market trend is upwards for container adoption. So why would someone containerize their application? So the key benefits for containerized application is that it requires less system resources, and as compared to the traditional virtualization, you can basically use less resources and can run your application. Increased portability. So container images are supposed to be immutable, so they can be run on one platform or the other because they are packaged with the runtimes and the supporting libraries. Greater efficiency because they can be rapidly built, deployed, and patched. Better application development because containers, since they are easy to build and patch, they are well suitable for agile and DevOps philosophy that help teams to accelerate deployment, testing, and reduced production cycles. More consistent operations because it solves the problem of running on my machine and not on production. So basically, when you package an image, it is independent of the platform. So you have like that the application and its dependencies are packaged along. If it's run on the developer's laptop, it surely would run in the same way as in production. So let's look at a short example on how you can basically containerize a Golang application. Prerequisites are preferably Linux operating system, obviously Golang installed, container build tools like Docker, build tools like Maven, and Git version control system. So let's define a very basic Golang web app. Here I am basically creating a root path, and on that root path, if you hit that root path, it would basically return you a simple hello world string. So in order to basically build this, we write Docker files. So in order to create an image and a container, eventually you basically have to package the dependencies along with your code. So as you can see, I have a sample Docker file written over here. So from the start, you can see that it says from Golang 118, which is the Golang version, and I'm using the first base image as a builder, and I'm just copying my go.mod and go.sum files. In the fourth step, I am basically downloading all the dependencies. Then I basically copy the main function, which is the main.go file, and then I basically build that with go build and generate a binary file called hello. And the interesting part here is that the resultant binary does not need Golang language to be packaged with it. So what I'm actually doing that here is that it's a multi-stage build, and I'm using another lightweight container called distroless, which is provided by GCR, which is basically a distroless, a very minimal container image. And I'm just copying my binary that I just built and just exposing 8080 on the container, and the last command says that whenever the container starts, just execute this binary called hello. So there are some basic best practices that are suggested by the company Docker, which I have given the link that you can refer to it later on. So in order to we have a Docker file. In order to build the image from the Docker file, you have to run a command called docker build. So when you build with the docker build, you have to basically suggest a tag. Here I am basically creating a tag called docker.io Osama Ahmed Khan, and the application repository name. So it would use my account and create an image. This image will not be pushed to the image registry, but in order to push that, we would basically, after this is built, we would basically run it, right? And you can basically run your resultant image by docker run, and this here is port forwarding, and basically you can port forward your application on your system, and then hit 8080, and then you can have the hello world message. So tying it all together, you can use a makefile. Makefile are battle tested automation tool. It's used mostly in all of the open source tool chains and open source projects, because it makes easier for the automation. You basically define targets, and then use that targets to execute some commands, and it is an easier way to standardize those automation steps in CI/CD pipelines, because you can basically execute a target, and the pipelines don't have to be changed if you want to change the behavior of your of the steps in actual. So this is a very good tool for automation. So let's talk about the CI/CD pipeline, or what we refer to as basically a DevSecOps pipeline. So as you can see in this cycle, you have build, basically you plan, you code, you build, you test it locally, and then you release. And in the operation cycle, you basically deploy, once the application is deployed, you operate and monitor, and when you want to make changes, then you start the cycle for development again. And security is baked into both of the cycles. So when you're coding, you have to be careful of the packages that you're using. When building, you have to be careful how you are building. Testing, obviously, in this whole cycle, security is the key component, where it is not seen as a later step, but it's actually essentially is the pivot around which you basically uh, plan and run your software. So CI/CD, the most popular choice and the most suitable choice for your application are GitHub Actions. So basically, GitHub Actions is a CI/CD automation tool, which is provided by GitHub accounts. Whenever you sign up on GitHub, it provides a free tier with 2,000 minutes, which are enough for a small project. If you want to have multiple microservices and complex CI/CD, you might want to look into purchasing an enterprise account. So GitLab runners are basically containers that are managed by GitHub itself. So GitHub has their own infrastructure, and they have these runners, which are basically containers, and you define steps how you want to build and test your application, and those steps basically run in essentially some other containers which GitHub manages. So the biggest plus point in GitHub Actions is that it has a marketplace where you can basically use a ton of reusable actions. So people are contributing, some are verified, some are unverified, but you can use those actions to automate your CI/CD pipeline. Some other alternatives for GitHub Actions are Jenkins, but Jenkins would basically you would have to deploy Jenkins and manage, so that's an additional cost. The Jenkins has to run somewhere, and then it has to be properly maintained, because the plugins need to be updated. So that's another thing you would have to care about. Then recently, a very interesting tool called Tecton became very popular because it's container native. So you basically run your CI/CD pipeline in containers that actually runs on a container platform like Kubernetes. And then there is GitLab CI, which is of course provided with GitLab. GitLab supports runners like GitHub Actions, but then it lacks the marketplace that is very reusable and has a plus point with GitHub Actions, where GitLab CI lacks. So you would have to write all the automation yourself. Talking about release strategy, so the most popular strategy and the safest approach is trunk-based development, where you basically run your CI pipelines on every pull request open to the main branch, and then you run CD when it's merged into main, and you always release your software from the main branch. If we compare continuous integration with continuous delivery, so you can see we have most of the steps are same. This is based on the best practices around open source software and open source projects use. So you would see the common steps like code linting, static code analysis. You build it, you test it, and then you package it into a Docker image. So the key differences in CI and CD is that in CI you would basically generate an image which can later on be used for testing and QA purposes. But if you're on the CD cycle, then you would have to semantically you have to use semvar tagging and release your software in a proper major minor patch versioned strategy. So in this case you would have a better understanding of your versioning system. And then you can scan your image for vulnerabilities, fix it report it, and then obviously fix it in the as required. And when you want to deploy your applications on Kubernetes, you have the option for generating Kubernetes in your pipeline as well, and then scan those manifests for security and misconfigurations. For CD, you can basically release your application. For, let's say, if you have Golang, you might want to build your Golang application for different architectures and generate binaries for different architectures, because your application might be consumed not only in Docker, but maybe someone wants to just grab your application and run it locally. So you might want to consider generate proper proper binaries for different architectures and properly tag your releases. And the last and the most important step is notify. So if your pipelines passes, either it's a CI or CD, you want to notify the pipeline result in a Slack channel or by email or whatever medium you actually care about. So we have basically set up a CI/CD. We have containerized an application. We have the CI/CD in place, but where would we run this container image? Kubernetes is the most popular container orchestration tool. So we have popular cloud managed services. Amazon's EKS is one of the most popular managed Kubernetes services, and similarly all the hyper clouds have some sort of managed Kubernetes services. So Amazon has EKS, Azure has AKS, and then there are some enterprise distribution of Kubernetes as well. The most popular choice is Red Hat's OpenShift. Then we have Canonical's Charm Kubernetes and VMware's Tanzu, and many more which are not mentioned here. So when we deploy our application, we after CI and CD cycles, we also want to deploy our applications continuously. So for continuous deployments, we use GitOps, which has become the de facto standard for deploying your application on Kubernetes. And GitOps basically is a strategy where you declaratively define what needs to be deployed. And this a lot of tools have came up to provide a solution for GitOps. GitOps actually stands for Git operations. So tools like FluxCD, ArgoCD, AutoApply, these are some popular tools which follow the GitOps strategy for deployments. The principle is the same. Any tool that is called a GitOps tool would basically fetch the latest state from the Git repository and basically apply those Kubernetes manifests in a Kubernetes cluster and repeat this cycle. And when these Kubernetes manifests are applied, basically Kubernetes just pick up those manifests and pull the required images and run those images as containers. And since GitOps tools are continuously polling the Git repository and continuous looking for changes, so whenever an image is updated on the Git, the GitOps tool would basically fetch the latest tags and apply and roll out the new application version. So for the demo, we have basically the following environment. It's a simple Golang app that we just containerized. We have a CI/CD pipelines written on GitHub Actions and a continuous deployment via Flux CD. And I am using a local CRC for my Kubernetes environment. CRC is for OpenShift as Minikube is to Kubernetes. So it's a single node cluster and it would basically essentially it's OpenShift but a single node OpenShift. So let's move on to the demo. So I have locally deployed a CRC which is as I mentioned is a single node OpenShift. So here we have an application already deployed. So it's basically hello demo. We have 3 containers running, and if you see here, this endpoint basically shows us hello world. So let's look at the CI/CD pipeline. This repository, which I'll send the link to, is basically a Hello World application. The steps defines in the CI/CD, which we will see later, but we're using a Sneak as a static code analysis tool, image scanning tool, and Kubernetes infrastructure as code analysis tool. So in this so I would basically do a change in the code, and then we can see how the CI/CD pipeline goes through. So here I have this repository cloned locally, and as you can see, we have a root path where we are calling the hello function from the hello package. So here I would just change hello tech world, and I would basically fix my unit test as well. So I will basically locally test here by calling make target, which is make docker build. So so this will basically create a local get tag for my application by building a new tag. So now that the docker build is successful and it basically generated a tag, I would just test my application if it's running by a make target called docker run, and then I can validate that it's actually running fine. Now I can basically create a pull request for it, and open a PR to the main branch. So I have changed just one called tech word and fixed it in the test case as well, because the test case is actually verifying this string. So as soon as I create a pull request, the CI pipeline will be triggered, and I can see that in action in my PR. So if you check in the details, you can see your job running and all the steps that we have defined in the CI part. So while this is running, let's look at the CI pipeline. So this is what a GitHub Actions file look like. So you can basically describe how you want to run when you want to run this pipeline. So I'm running on pull requests opened on the main branch, and it will ignore if this pattern it will ignore the pipeline completely if the changes are made on this file pattern. Then you can basically describe some environment variables. I have defined that the Docker file path would be Docker file, which is in the root directory, and then the Golang version would be 118 that I'm passing. So it will basically check out the code. It would basically fetch the code. It would set up the Golang, then run linting, then normal language native static code analysis, which is right now I have defined as vet. So the Golang vet command would be used to statically analyze it. Then I'm using Snyk as a static code vulnerability analysis tool, and and I'm using Snyk token from the GitHub Actions secret. So what it actually does is, instead of defining the token directly here, it can fetch from GitHub secrets. So if you want to create your GitHub secrets, you can basically just go to settings, and in actions you can in secrets, in actions you can basically describe these secrets, which will not be shown for security reasons, but you can refer them in your GitHub Actions pipelines as secrets dot whatever the secret name is. So I have some already defined, like Snyk token and some other. So the Snyk basically runs code vulnerability analysis, and basically we have set a threshold of low. So any result with slow would basically fail this action, and this action would be basically um, um, print all the results for the code vulnerability analysis. And in the next step, we are basically uploading the results to GitHub code scanning. After that, we basically test our code, that is running Golang go test step, which is defined in the make file. So if you look at the target make test right here, you would see that I'm running go test and run test for all the packages. And then I generate a tag by taking the pull request and adding a random SHA hash to it. So every pipeline run would generate a unique tag. And these steps would basically allow me to use Docker commands. Since it's a container, it requires special action. So in after that, I'm logging into the registry. Again, secrets coming in from GitHub Action secrets, and so I would have to create an image repository path where I want to push the built image, which is right now I'm pushing all my images in Docker Hub registry. So in the next step, I build and push my image to the Docker Hub registry, and then I use Snyk again for scanning image for vulnerabilities. Again, some different arguments, but but the results are uploaded to the GitHub scanning, and then I basically generate Kubernetes manifests for for the newly built image. This would basically uh, create Kubernetes manifests from a chart defined right here. So if we look at the make target, which is make manifest, so it will basically get the latest version tag, which is for this random hash tag that we generated, and then replace the values file and basically create Kubernetes manifests in the directory called Kubernetes. So right here it would basically override the version image, right? And in the next step, we are scanning those Kubernetes manifests for any misconfigurations or security vulnerabilities. And then again, for every scan we upload this results, and then we add a step. If all these are passed, then we basically add a comment to our PR that the build has been successful, and you can basically use the following command to fetch your image and test in any environment that you want. And then the most important part is that we notify. Right now I'm using Slack as the notification channel, and I have basically send not failure and success results to Slack every time this CI pipeline runs. So let's look at our pipeline. So the CI pipeline, I go to my pull request, and I see that the GitHub Actions has commented, as I mentioned in the second last step, and here I can see that the CI pipeline basically passed, and I have these code scanning results for container, ISE, and code, which I can also see from here. So there are, so for all the tools we have 0 alerts, so the pipeline passed very nicely. So let's look at the pipeline. So here are all the steps, and you can basically see the logs for every action, and all the pipeline, all the steps passed very nicely. So notify failure was the action which was skipped, because the pipeline is set up in a way that this fires only when the pipeline is failed. So I have this notify Slack. So this it sent a success post to the appropriate configured channel. Now I will merge this pull request, and then the CD pipeline would basically start running. So so we can see the CD pipeline from this commit message directly here, or the actions tab. So this was my CI pipeline that ran just 10 minutes ago, and this is the CD pipeline. So meanwhile, while this is running, let's head over to CRC. And I have old version running in a project called Hello Demo. So if you see right now, this container is at version v0.0.6. So for continuous deployment, as I said earlier, we are using Flux CD. So Flux CD is basically a GitOps tool, and so it will basically, I have configured that so the Flux will basically watch this repository, and it will basically poll this repository. We have set up an SSH connection, so whenever the Flux start, it outputs an SSH public key which you can add into your target repository, so it can talk to the repository without the username and password. So directly it can fetch and talk to your repository, and it will watch the main branch, and it will apply all the manifests in the path called Kubernetes. So as I mentioned earlier, we are generating our manifests in a directory called Kubernetes. So right now it's at version 6, and as soon as our pipeline passes, which it did, it will basically update the Kubernetes file. So if we look at it, so the new version is 0.07. If we git blame, you can see that the pipeline the version was changed and pushed by version was pushed just a minute ago. And let's go check our Flux tool, which is deployed in the default for this purpose, but you can it's a general practice, it's a good practice to deploy it in a separate namespace. So you can see that it basically compares if I can increase the font, we can see that the latest so it compares the hashes for the old and the new, and it found that the new was 9.6 as compared to the old 5.5f hash. So something must have changed, so it will apply the new change, and it would apply the manifests in the Kubernetes directory. So if we look at our hello demo, we can see that the new application, the new version got deployed just a minute ago, and we verify the tag, we can see that it's the new 07 tag. So so this was basically if you look at the deployment section, it's basically a rolling update, and we can specify how what is the max surge, what is the max unavailable. So you would have zero downtime in your application deployment. And in these manifests, we are also defining an ingress, and OpenShift would basically expose your application on the host called hello, and this is the domain of the test cluster. So it will basically talk to the service go hello world defined above, and it will basically route all your traffic to this go hello world service on port HTTP. So if I go to network routes, OpenShift basically takes the ingress and creates a route for it. So it's an OpenShift way of doing that, but you can basically expose your application via some ingress controller. So OpenShift is using HA proxy as for exposing your application to the outside world. So right here, this was the old message from 0.0.6 version, but if I refresh it again, it says hello tech world. So that change was made by this by us just now. So this is basically an overview of the how the CI/CD pipeline would work. Okay, so let's talk about um, how we can improve the reliability of our deployments on a Kubernetes platform. So as I demoed you earlier, we can use multiple replicas. So define requests and limits on your containers so that they do not consume all the memory that is available with the Kubernetes nodes. So for efficient utilization, you should always define quotas and requests and limits according to the project and the team, and a suitable uh, um, requests and limits. Then you can define service monitors. The most popular monitoring stack is the Prometheus stack, which is Prometheus, Grafana, and Alert Manager. So you can basically fetch all your all your matrices from your application via Prometheus, and then you can visualize your matrices in Grafana dashboard. And if you want, let's take an example of an e-commerce application where you have an inventory, and you want that whenever the inventory goes below a critical level, let's say 10, you get an alert. So you can basically define a Prometheus rule which says scrape your application and get me the metrics, and if those metrics fall down below 10, generate an alert. So the alert manager will generate an alert, and you can forward your alerts to multiple targets of your choice, which would be Slack, email, and there are plenty of options available with you. And alert managers alert manager supports a lot of tools. Then you can define pod disruption budgets, where you can basically describe how many pods be should must be disrupted in an event of an upgrade. So that you can basically have your application up all the time. Then you have horizontal pod autoscaling and vertical pod autoscaling. So this is when you have a huge traffic on your application and you want to scale your application automatically. So you define a custom resource, Kubernetes resource called horizontal pod autoscaler, and you can define that I want to scale my application if the usage for all the pods go above 50%. And you can basically define your range that you can define a min and a max, so that the application can scale on the basis of the load that it's facing right now. So it will horizontal pod auto scaling would basically horizontally scale your application, and vertical pod auto scaling will basically increase memory and CPU as per your definition. But vertical pod auto scaling would not be very suitable with GitOps, because you would have requests and limits defined in your GitOps repo. So you might want to choose carefully when using auto scaling. Then you have an uptime monitoring way of monitoring your application. So you can basically use an external monitoring service like Uptime Robot or Uptime, and you can basically create a monitor for your public URL, and these services will basically ping your URL, and you can set an alert if the result for hitting this URL is not 200. So if it's not 200, then just email or Slack, send a post to Slack, and you can know that your application is down, and then take necessary actions. So uptime monitoring is basically very helpful when you want to monitor your application and reduce your downtimes. Thank you.